So let's get into the default implementation, since we mentioned earlier that while broadcasters are able to express their preferences via their selection implementation, the default is pretty powerful. So how does the default work today? The way that it's broken up is there are two phases. So the first phase we call the discovery phase. So this answers the question, which orchestrators should be considered for selection in the first place? And the second phase is the selection phase. So once you have discovered a set of orchestrators, which of those orchestrators should be selected and in what order? These phases are run per stream. So for each stream, a broadcaster would run the discovery phase, followed by the selection phase. And the discovery phase roughly follows this basic outline, which is the broadcaster is going to send these discovery requests to orchestrators, and it's going to filter out those orchestrators based on a few criteria. Examples include price, ticket parameters. So for example, you'll filter out an orchestrator that charges a price that's too high. And
just to clarify that,
yep.
a lower price doesn't help you get selected over one with a higher price if they're both below the price the broadcaster is willing to pay, correct?
At the moment, yeah, that's the case. There is no, as long as the filter is only based on a maximum. So as long as you're below the maximum, there isn't any additional prioritization from there at the moment.
Right, but you could see in the future how an implementation might want to always select the lowest price node first.
Yeah, definitely.
Thanks.
So after the filtering process is complete, the last step of the discovery phase is that the broadcaster is going to take, at the moment, the first 8 eligible orchestrators to respond in order to construct what we call a working set. And once we have that working set, we move on to the selection phase. So the thing to note with the construction of the working set is that after the filtering process is done, the way that orchestrators are added to the working set, it prioritizes how fast you're able to respond to those discovery requests. So generally, if you're closer to the orchestrator, you're going to be responding faster to those discovery requests and have a higher chance of being included in the working set. After the discovery phase, we move on to the selection phase, and the selection phase at a high level follows this outline, which is the broadcaster is going to keep track of the last known latency for each orchestrator. So as if people recall, we treat latency as the time for the broadcaster to receive transcoded results for a video segment. So the broadcaster is going to keep track of the last known latency for each orchestrator. And using that information, it proceeds to do the following. If the orchestrator with the lowest latency transcoded the last segment in real time, we will use that orchestrator. So if the last orchestrator that you sent the segment to has been keeping up with the stream in real time, then the broadcaster is going to continue sending segments to that orchestrator. And we use real time as kind of the rough threshold, that rough performance threshold to base a lot of decisions off of, where we really want to be real time or faster. If there are orchestrators without a last known latency and the current orchestrator with the lowest latency is not transcoding in real time, this is where stake comes into play, where we use stake to determine who we should try next. So we will do a random stake-weighted selection of the remaining orchestrators to determine who we should try next. This is basically saying the last orchestrator that we tried clearly isn't keeping up based on the performance that we want. let's try another orchestrator. And we use stake to determine which orchestrator to try next. So that's the second criteria. And then the last criteria is just that if all orchestrators have last known latencies already, and then we'll just select the fastest one available to us. So this is a basic overview of this, how the selection decision-making process works. There's a couple more details that we could get into later if we wanted to, but I think the thing to highlight here is that this initial default implementation is very quote-unquote greedy, where at any point in time, it just tries to make the best decision based on what it knows at this point in time.